Hi, my name is Sean, and this is my project for CS50 Traffic. So in this project, we're going to write an AI to identify which traffic sign appears in a photograph. But before I go about explaining anything, let me just run this program because it does take some time to run. So basically, this problem is split into two different parts. The first is loading data, which is loading data from a data directory. So as you can see over here, in the load data function, we write a few lines of code. So you can see the documentation for the OS module and OpenCV, which we are using here at the respective websites. So next is the more interesting part, which is the actual writing the actual model of the AI. So here we're going to use a concept called convolutional neural networks, and basically we have different convolutional layers and pooling layers, followed by hidden layers to train our data on. So as mentioned in the problem set, what we can do over here is to vary the different properties of this neural network to see the outcome. So I've managed to play around with it a little bit to end up at the current efficiency. So let me just go into this README page. So for first test, as you can see over here, I have varied the default number is I've set one convolutional layer, one pooling layer, and 32 3x3 kernel, and one 3x3 pool size, together with one hidden layer and a 0.5 dropout. So what the convolutional layer does is it goes through the image and it applies a kernel filter. So depending on what kind of features you are going to focus on, you want to highlight, then that will be how you adjust the kernel filter. So later on we'll discuss how increasing or decreasing the size of the kernel filter, how does it affect the data. So next is the pooling size. So pooling just means looking at a certain number of certain grid. In this case, it's a 3x3 pool size, 3x3 grid of pixels in the image and choosing the greatest value in this case. So we can also go on to see in different situations how different size of grid will affect the results. So over here in the first test where everything is like the default, you can see here loss is 0.3 and accuracy is 0.938. So what we want to do in this problem is to decrease the loss as much as we can and also increase the accuracy of the model. So in the second model, what I did was I increased the filter size for both the kernel filter and the pooling grid to 5x5. And as you can see, it's greater loss and lower accuracy, which means it reduces the performance significantly. Next, in test 3, what I did was I added 3 hidden layers, so I increased the amount of layers. So, well, it does seem to help with the overall performance of the program. So over here, you can see lower loss, so more hidden layers to train model to reduce loss. Okay, next we go on to test 4, which is, I've changed everything slightly. So increase to 4 hidden layers, and this time I vary the dropouts. So dropout is basically trying to prevent a situation of overfitting where we overtrain our model to fit into a specific data set. So what we want our model to do is generally train to the data set such that when different data is fed into the model, we can produce a consistent result and not only work for a particular data set. So what dropout does is it removes certain nodes of the neural network and as the model is training based on the data. So in this case, it's 0.2, which means 20% of the nodes are being removed, and twice of this at different areas. So yeah, leads to lower loss and better accuracy. So yeah, improves the model generally. And the final test, which is the current code, which we are running over here as well, I've increased the number of convolutional layer and pooling layers, which means after a convolutional layer, we'll pool the data and then it'll run it through another convolutional layer where another kernel filter is applied onto the data, and then run it through pooling again. So we repeat this step a few times, and then afterwards we feed it into hidden layer. So I realized that the numbers in your hidden layer matters as well, although I'm not too sure exactly what, but I've decreased it back to 3 and I've just included one dropout with a value of 0.4, 40%. So this seems to be the best result of all the different tests that I've been through. Yeah, it does put quite a strain on your computer. And now we'll just wait for the last epoch to load before we can see the result. Also, I want to mention that how effective and how fast the model runs also depend on your computer's GPU. My computer is I'm using quite an old laptop, so yeah, it's quite slow. And it heats up your laptop quite a bit as well. So the final result, yes, we have achieved loss of 0.11 and accuracy of 0.96, which is fairly high. Not as high as my previous test, 0.898, but I think this is good. So that sums up my project for this AI model.